Hello, these are some examples of balancing equations. Can you pause the video now, try them all yourself, and then you can go through and look at the worked examples. They get harder in difficulty. Example number 1, first thing you need to remember is that whatever's on this side of the reaction needs to be the same on that side. This is called the conservation of mass. So, how many calciums have we got on this side? We have 1. How many oxygens have we got? We've got 2. How many calciums have we got? 1. How many oxygens have we got? 1. So the first thing to notice is the calciums balance, but the oxygens don't. So what have I got to do to this side? Well, I'm going to have to double it. So I'm going to put a big 2 there. That will get me 2 oxygens there, but it will also double my calciums. So now my oxygens match, but my calciums don't. The final thing I would have to do is to get 2 calciums on both sides is a big 2 there. Next example, again, I'm going to make sure that I've got the same number of atoms on both sides. So I've got 1 aluminium and I've got 2 oxygens. I have got 2 aluminium and 3 oxygens. So now you're looking at it, you need to decide, am I going to match my aluminiums first or my oxygens first? Well, in this case, I would always try and match the oxygens first because you've got an even number here and an odd number here. So it's going to be much easier sorting those first. So because I've got an odd number and that side's even, I'm going to double this to leave me with 4 aluminiums and 6 oxygens now. Now it should look a bit more simple for us. So to get from 2 oxygens to 6, I need a big 3. And to get from 1 aluminium to 4, I'll need to times that by 4. So there's your answer. Again, we're going to start with exactly the same process. Fluorines 2, potassium 1, bromine 1. Fluorines 1, potassium 1, bromine 2. So now we need to look at, let's try and do the bromines first. So to get from 1 to 2, I put a big 2 here. That times all of that by 2. So I have a 2 and a 2. Bromines are now sorted. I now need to make sure my fluorines and potassiums on this side are doubled to 2. So 1 to 2, 1 to 2, a great big 2 there does that. Now I've got 2 of every atom, so it's all balanced. Okay, starting to get a little bit harder now, but let's do the same process to start off. So nitrogen 1, hydrogen 3, nitrogen 1, hydrogen 2, oxygen 5. So looking at this example, you can see that I've clearly done it wrong because there are no oxygens on this side, so this equation is wrong. Okay, so let's count everything on each side. So we have nitrogens 1, hydrogens 3, oxygens 2, nitrogens 1, hydrogens 2, oxygen 1, 2, 2. Okay, now what I'm going to try and do here is leave my oxygens till last. The reason I'm leaving oxygen till last is because they're an element all on their own there and they're not combined with anything. So let's try and sort out hydrogens first. Well, might be I've got an odd number here and an even number here. So first of all, I want to double this side so I can get myself an even number. So I'll put a big 2 there. That will give me 2 nitrogens and 6 hydrogens. Okay, I will also have to sort out the nitrogens. So 1 to 2 there, I'll put a big number 2 there. Give me 2 nitrogens. This will now give me 1, 2, 3 oxygens. Finally, I'm going to do, to get from 2 to 6, I need to times that side by 3. So I'll put a big 3 in there. That will get me 6 hydrogens and 5 oxygens now. So my nitrogens are balanced, my hydrogens are both balanced with 6, and my oxygens aren't. So the last thing I'm going to try and do is turn 2 oxygens into 5. Well, the multiplier to get from 2 to 5 is 2.5. But I can't put 2.5 here for the oxygens because it needs to be a whole number. So instead of putting 2.5, if I double everything else, well, double 2.5 is 5. So if I put 5 there and double everything else, so that's 4, and that's 6. This is now the balanced equation for this reaction. Thank you.